Yeah, so hello and welcome back again to the Programming Bootcamp. My name is still Gabor Szabo. Nóra, hello, how are you?
Hi, good.
It's nice to have you back, and it's again your turn now that we have these exercises. Let me show just for a second, where are we? So I'm sharing the screen. So just to remind you, this is not you, Nóra, because you know, but anyone who's watching the video for now, first time, this is the Programming Bootcamp, and here's the link to the website, and we are actually in the lists chapter, and here we had a bunch of exercises about queue, stack, and I think also MasterMind. And now I'm going to hand it over to you, Nóra, so you can explain your solutions, and we can go over them and see what might be improved there or not. Okay?
Right.
Okay, so yeah, now you can share it.
Okay, I'll share my code then. Yeah, can you see it now?
Yes, yeah, I can see. I just have to move
Great.
it to the other screen, so I will not stare too much above my screen. Yeah.
Right, so this was the first exercise, which was queue. It was about us adding names into a queue and then calling the next one as in a doctor's office or something like that. And then we had another function which would say who is left in the queue and then exit the program, and another function where we could press S, which would show the number of elements in the queue.
Yeah.
Right, so here I used this DQ module that we talked about in the, chapter.
The module is called the collections is the module. DQ is just the function or an object. Yeah. Okay.
Right. So then I used the DQ function from the collection module, where I made this list or queue, and every time there was a name entered, if it was a name, then it was appended to the list.
Right.
And then
this is the default behavior.
This is the default behavior which I put at the end.
Okay.
But otherwise, there were three other conditions. If the action, if the input was n, then we had to say we had to print the first name in the queue, which I put in a condition as well, so that we wouldn't get an exception in the case where the queue was empty.
Right.
So if the queue was not empty, if the length was more than, or if the length is not equal to 0, then I printed the first element of the queue with this pop left method. And in other cases, obviously if the length is 0, then I just print the queue is empty.
Right.
And then in the next bit, if the user presses S, it's just simply printing out the length of the queue. And then if the user presses X, then I exit and print out the remainder items in the queue.
Oh, this exit can get a list. I didn't know that. Okay.
It apparently works.
Okay, I didn't know that. Right, good. Looks good. Two notes I have, I think, here, but it looks really good. One of them is a common thing that we do a lot when we create a variable, and in the name of the variable we use the type of the variable. So you have like a queue list here, which is totally understandable, because you sort of want to know something. In many cases you are actually thinking about it as some list, and that's really need to be part of the name. But in many other cases, you don't have to change anything here. Just saying that in many other cases, it's sort of an unnecessary addition and entering the name of the type or the type of the variable in part of the name. Actually, there is a style that does this, and not necessarily with the full name, but let's say calling it L, putting an L at the end, or to indicate that it was a list. And it is called the Hungarian notation. So,
oh, nice.
yeah. So anyway, it can be used, but in many cases it's a little bit strange that why do I have to explicitly say the type when it sort of should be obvious? Well, obviously it's not obvious, so that's why people use it. But that's one thing. And the other one is that in the line 12 in the if condition, that's sort of strange to me that you say if not and then compare equality. Probably
Right, so should I?
Not equal, right? I would say not equal. That's the first thing that maybe I would change, or I would say greater than 0.
Right.
Sort of, because that is still positive and it sort of expresses what I really mean, that if it's bigger than 0.
Right.
Yeah, and that's it. Or I would swap around the two things. So I would say that when len is equal to 0, then print out the queue is empty, otherwise print out the next is.
But that doesn't really change much, does it?
No, it's just the thing is that
where's the emphasis, I suppose?
Well, yeah, probably, but it's also that at least I prefer that the conditions are positive. It's easier for me at least to think about them than to have negative conditions. Now this is a positive condition already, so that's already good.
Right.
But if you want to specifically check or compare it to 0, then the positive part is that you switch around. Okay, let's go to the next one.
Right, the next one was stack, right, where we had the reverse Polish calculator, which was something very new to me. Apparently. Yeah, so here, obviously the things that we needed to do is have an input, which could be either a number, an operator, or some action like if the user presses X, then it should exit, and if it presses S, then it should show the values in the list that we created. So here I made the list, which I called calculator, had the input, which could again be anything, and if it was a number, I just appended it as a float into the calculator list. And then I had the two actions, which were S and X. With S, I just printed out the list and then continued. And if X was the input, then I just exited printing end. Yeah, and the rest were the operators. Now here I had a condition which was probably not needed, but I thought it would be something fail-proof, that I said that the operators should only be accepted if the length of this list was more than 2.
Yeah, sounds
more
good.
Than or equal to 2, and if not, then I print out this statement and continue back to the end, back to the beginning.
Okay.
But obviously I couldn't put the equal sign equal sign operator in this condition, because that can also work if there is just one element in the list.
Yeah.
So I had to just take that out. Again, if anything else is entered, like any string which doesn't have a meaning in this function, or if it doesn't have, or if it's an enter, but there is nothing in the list, then we would get an exception. So I had a little bit of problems with this. I tried to solve it, but I didn't really get anywhere with that.
Mm-hmm. Where would you get the exception?
So if you press enter, but there is nothing in it.
Ah, okay.
Mm-hmm. Nothing in the list before any of the numbers are added, then that would be a problem, I suppose.
If you put an equal sign.
Yes.
So you can check if the calculator has at least one element, no?
Right. Yes. Yeah, I can do that. I just didn't want to add another condition, because I thought it would be too long. And again, I tried something else instead of.
It's
printing.
Better to have a long program that it's works.
That's true.
Good. Yeah.
Right. So I can add that. And one thing I also wanted to change, but I didn't quite know how, was to not have to type this in each of these conditions. So here what I did in another one is just to put it out if the length is greater or equal to 2. And obviously the input wasn't any of these. Then I would just have it here, and then I don't need to write it again, type it again.
Okay.
Below every condition.
Yeah, that looks better.
Yeah, that was basically it.
Okay. Okay. So a couple of notes here. One of them is that you can swap around the condition to change the condition on line 24 to be the opposite, and then have the short part, what is now 45 and 46, being the first part, and then you are done, and then you can then have everything that's now inside the if condition.
Right. Okay.
So that's one thing. The other thing is that you want to, if you'd like to do it, and I'll wait for a second till you finish it.
So that would be this bit here, and then
you can
this bit.
Right.
This only works if I want to print these. Right. This is the same, right? But you wanted me to out then, but then I would need to copy this into each condition.
No, it's okay.
Okay.
You just out then the whole thing.
Okay.
So this
because there are continues everywhere.
Yeah, there are continues. Yeah. So and there's one more thing here is that now that so what happens if the user types in something which is not a plus, not a.
Yeah, that was my problem.
So right now, what happens is that you take out the two values, and then you do nothing.
Yeah.
Right. So you could, for example, check before you do the whole thing that whether the whatever you got is one of the acceptable operators.
Right. So should it be like if what was it, num is, and then should I do or?
Well, that would be
that would be very long.
That would be very wrong. Now, how could you say? Now, I don't know if how to sort it, but you could have actually a list or even a string
of operators
of the acceptable values, and then you can check whether num is in the list.
Right. Okay. So should I make that list somewhere more up or here?
You can, for now, just put it here, and then you can move it ahead.
I don't need do I need a separate variable, or can I just add?
No, you can just put it like this. Yeah.
Okay. So it should be right. Or no, it should be strings. They are strings.
They are strings, and the equal sign it's already.
Oh no, yeah, I don't need it. Yeah.
It's already not there.
Right.
So because these are all okay, so because these are all individual characters, you could actually create a string, and then check whether the num is in that string.
Okay. Right. Okay. So like this. No. Sorry, I'm not yet very good with these.
Okay. No, this is actually totally annoying with editors. It should be useful, but it's annoying me as well when you type in a quote and then it already adds you another one. But if you are a person who gets used to adding one and another one, then this totally annoys. So welcome to the club. And but it's not an equality now. You need to check in and then do something.
Oh yeah, right. Here should be if not, right?
Yeah, but you would normally you write it on the other direction. So if say if num not in, that's how.
Okay.
So this is a strange thing that Python allows, because it's not how most other programming languages would do probably, but you can write in Python this way because it's more English-like.
Right. So.
Yeah, you are very kind to your
Yes, I
to your
suppose.
please and all kind of things. No, you didn't give the right operator, and that's done. Yeah.
And then here I should continue, right?
Right. Yes. Yeah.
Okay.
One thing I would put, for example, here, an additional thing that in the print statement, I would even probably add the actual value that I got.
Okay.
It can be helpful if in case. So in that
Right.
in the print message, I would just add the content of the. Yeah. Okay. Great. So I think yeah, it's a great solution. Actually, you went way further than I did in my solution. So I didn't have these all these verifications whether you have enough parameters or the parameters are correct or all kind of things. I think I didn't have. So it's a much nicer solution. Thank you.
Right. And then we had one more, right? The MasterMind game.
Yeah, the MasterMind.
Okay. So here, we had to ask the computer to think of a 4-digit number where all the digits, 4 different digits actually.
Right.
And then we would try to guess, and the game would evaluate our guess, right?
Okay.
So here I just created a list of all the digits. I didn't know if I could do it any other way, but this seemed straightforward for me. And then with this random sample that we used in the numbers chapter, I picked a sample of 4. Then we could make the computer print it, but obviously if it is actually a game, then there is not much. It's only for the debugging, I suppose.
Yeah.
And then again, I added the score sort of already, so that at the end we would see how many steps it took us to guess the right
good. So you know
number. Then obviously we have the user input here, and then obviously with every guess the step would increase with 1. And then here I made a list, an empty list, where I would put the stars and the plus signs that the computer gives for as a feedback. Now I'm sure that there is a way to do this better, but I added another loop in the while loop that we had for each guess, and went over the digits of the entered of the input here.
Okay.
And with every, well, not digit, every character, that I would make that an integer and compare it to the number at the same location from the number that the computer looked at. And if it's the same, then I would add the star in the list, in this list I created, solution list. And then another condition, if it's in there, then it would give us a plus.
Okay, so if it's not the same location, then you check if it's
in there. Yes.
there. Okay.
So that's why I had to add these.
Okay.
Values. And then at the end, I just had this condition. If we got to the 4 stars, which would be, we actually guessed it correctly, then I would print out, okay, you guessed it, and then this many steps. It took you this many steps.
Nice, nice.
But otherwise, if this is not true, then I would just print out the list with the asterisks and plus signs.
Yeah. Okay. Well, sounds good. Did you play it?
Yes.
Okay. How was it?
And it works. I'm not very good at this game, but other than that, it's okay. Okay,
great. So that's why there was the other part of this exercise, which I think is way more difficult. I don't think that I even have a solution in the slides, where the computer tries to figure out turn it around the model, and the computer tries to figure out, and then you just let it play. and you don't have to worry about it anymore. One note here, I think the only one thing that I could say is that maybe it's better not to deal with them, these things as integers. Just deal them as characters, 1, 2, 3, 4, 5, 6.
Okay.
Okay.
But then I would have to make this as a list of strings,
yeah.
right?
Yeah.
Yeah. Okay.
Yeah.
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 Okay. So, right.
Yeah. Actually, so there is a way to make this now. So just type on the line 4, so you can have this example. You could say digits equal to list. No, don't write the list, just the word list. And then in parentheses range and 10. Parentheses 10. No, in the parentheses. Okay. And yeah. So the range 10 would generate something that can allow you to go over. So it's an iterator that will go over from 0 till 9. Right. The whole numbers, and then the list function actually converts it into an actual list. So this would create the one that you had above.
Here,
okay, right, is the
so
same.
These two are the same, okay.
Yeah, and if you also wanted it to make them strings, then you can wrap the whole thing into a map with a map function. So the list in front of the list now, in front of the word list.
Okay.
Type map. And then in the parentheses, you put str. Yeah.
Here again,
str, comma, and that's it. So now, and actually in this case, I think you don't, well, okay, not correct. In this case, you have to put the word list in front of the map. So you can remove that list, and you have to, because, yeah, list, and you don't need the internal parentheses. So that one, yeah, that one.
Okay, right. Now I'm confused.
So what does it? Okay, so the range generates this something that can go over from 0 to 9. It doesn't generate it, but then map comes in, and it goes over all of the elements. And what map returns is this something that can go over the elements that now are strings. Each one is a string. Okay, so remember, map will go over all the elements and run the str function in this case on each element. But it's still, what map returns is still not the list. It's still not just the possibility to go over those values.
Right.
Okay, and then when I call list on this, that actually goes over all the possibilities and creates a list of that.
Okay.
Okay. So, and now they are strings, not digits. And
so here I don't have to do this.
So you don't do this, and I don't know if there was any other place that you, and then maybe you don't call it num, but
that's something else.
Okay.
Here I don't need to change anything, right? Because it just chooses
no, it's the same.
For random samples, right? Okay, the rest is good, I suppose. No, actually, oh yeah.
Yeah, it seems that everything is out.
It's only here that I don't have to do this.
Yeah.
I just print.
You can just join them, yeah. Yeah. Okay. Good.
Right. I think that was it for this chapter. Like, I mean, not the chapter, like half chapter.
Yeah. Okay. So thank you for this. I think we are done with all the exercises now for now, right? Okay. So let's finish this video now, and then in the next video we are going to continue with the next part of this chapter.
Right.
Okay. So thank you very much for being here and for all the other people watching us. Okay. Bye bye. See you.